Now in core servicing, let's start with the first part, the three R's.
In this module, we will discuss three important processes within the HVAC industry.
In this module, we will discuss three important processes within the HVAC industry: refrigerant recovery, refrigerant recycling, and refrigerant reclaiming. Recovering is when a technician removes refrigerant from a system and stores it in an external container. When we recover refrigerants, we're not testing or processing the refrigerant in any way. All we're doing is storing it in a separate container. We recover refrigerants for a number of reasons. Remember, CFC and HCFC refrigerants have been phased out, meaning they can no longer be produced or imported. We recover refrigerants so that we can have supplies of CFC and HCFC refrigerants to service equipment with. You can think about recovering refrigerants like filling up a water bottle for the road. You store the water in a container so that you can drink it later. As we learned earlier, venting, or releasing CFC and HCFC refrigerants into the atmosphere, is harmful for the ozone layer. This is another reason we recover refrigerants, to prevent damage to the ozone layer.
Which of the following is not reason to recover refrigerant? To secure supply of phased out refrigerant? No. To prevent refrigerant venting and damage ozone? Yeah. To transfer refrigerant to another system? Yeah. To service equipment? Yeah. Oh, to service equipment. This. We don't recover refrigerant in order to transfer it to another system. We cannot transfer it to another system. Yeah.
Recycling is the process of cleaning refrigerant for immediate reuse. We recycle refrigerants by separating the oil from the refrigerant and using filter dryers to remove moisture and acidity from the refrigerant. You can think of recycling as washing your plate and using it again. When recycling a refrigerant, you're basically filtering out the contaminants so that you can use the same refrigerant again. Reclaiming is the process through which refrigerant is processed to new product specifications. After the refrigerant is processed, we need to verify its properties through chemical analysis. If a refrigerant is reclaimed, it has basically the same properties as newly manufactured refrigerant. Remember, since CFC and HCFC refrigerants have been phased out, we can no longer produce or import them. The closest we can get to new supplies of these refrigerants is reclaimed refrigerants. Reclaimed refrigerant has to meet the standard AHRI 700-2016 before it can be resold. You can think of reclaiming like refurbishing refrigerant until it's as good as new. Since the properties of the refrigerant are chemically verified before it's reused, reclaiming is a more precise process than refurbishing.
Reclaimed refrigerant can only be sold if it meets the AHR 700-206 standard. Yeah.
In this module, we discuss the three R's and how refrigerants are recovered, dehydrated, and evacuated.
Okay, the next one is recovery equipment.
In this module, we will discuss the various recovery equipment and techniques used in the industry.
All technicians need to be able to operate the equipment needed in their normal services. They must also follow the manufacturer's instructions on how to properly operate the equipment. Under Section 608, all new recovery equipment is required to have an EPA-approved certification label. This lets the technician know that the equipment is up to EPA standards and can operate on refrigerant chemicals. There are two main types of recovery equipment: system-dependent recovery equipment and self-contained recovery equipment. As we discussed in equipment requirements, system-dependent equipment relies on the pressure generated by the compressor to recover refrigerant. System-dependent equipment can only be used with appliances that contain 15 pounds of refrigerant or less. This means that for all appliances with more than 15 pounds of refrigerant, the technician must use self-contained equipment. Self-contained equipment can operate without relying on the pressure of the compressor. As we said, we use self-contained equipment for appliances with more than 15 pounds of refrigerant.
Self-contained equipment can only be used on appliances with less than 15 pounds of refrigerant. I think it's true. Oh, false. Self-contained equipment can only be used with appliances with more than.
When recovering refrigerants, technicians must use recovery cylinders. These are containers specifically designed to hold refrigerants. They have gray bodies and yellow tops. Only one type of refrigerant can be recovered in each cylinder. This is to avoid mixing refrigerants. As we discussed in refrigerant blends, blending your own refrigerants gives the refrigerant unpredictable temperatures and properties. It is also illegal to blend your own refrigerants. If multiple refrigerants are recovered in a cylinder, this mixture cannot be used. In addition, the mixture may be impossible to reclaim. If a technician discovers that refrigerant B was added to a system that operates on refrigerant A, they must recover the mixture in a separate recovery tank. For example, let's say a technician is working on a system using R22 refrigerant. If you discover that R410A was added to this system, you need to recover the mixture in a separate recovery tank.
Which of the following statements is true? Recovery tank have a gray bodies with yellow tops. Okay, multiple refrigerant can be recovered into one tank. No. It's easy to reclaim mixed refrigerant. No. Technicians are allowed to blend their own refrigerant. No. This is the correct one.
This is why technicians can only recover one type of refrigerant per recovery cylinder. If it is necessary to recover more than one type of refrigerant from multiple devices, you must use a separate recovery cylinder for each refrigerant. At the end of recovery service, technicians need to make sure that there is no liquid refrigerant trapped in the service hose. Any refrigerant trapped in the hose may be accidentally vented, which is not allowed under the venting prohibition. For all ozone-depleting refrigerants and their substitutes, there are special recovery requirements. These requirements affect all types of ozone-depleting refrigerants, including CFC, HCFC, and HFC refrigerants. For CFC, HCFC, and HFC refrigerants, refrigerant must be reclaimed to AHRI standards before being resold. We discussed this in Section 608 regulations. This means that if you recover these refrigerants, you can only use the recovered refrigerant in the same appliance or another appliance owned by the same person. For example, if you recover R22 from an appliance, that recovered R22 can only be used in the same appliance you recovered it from. You can also use it in another appliance owned by the same person. In order to use the R22 refrigerant in an appliance owned by a different person, you must send it to be reclaimed per AHRI standards for virgin refrigerant. In this module, we saw different types of refrigerant recovery equipment. We also discussed the various recovery practices observed while using these devices.
Okay, so we finish in servicing the 3Rs and recovery equipment. Now we'll check the factors that affecting recovery time.
In this module, we will define the term recovery time and discuss the various factors affecting recovery time.
Recovery time is the time it takes to recover a refrigerant. Generally, we want to recover refrigerant in the least possible amount of time. This is because the longer it takes for the technician to recover the refrigerant, the higher the chances of venting. The time it will take to recover a particular refrigerant changes depending on ambient temperature and hose length. Ambient temperature refers to the temperature within the system. As we learned in our essential chemistry module, temperature is a measure of how fast molecules are moving. If the temperature is low, that means the molecules inside the system are moving slowly. The lower the temperature of the system, the longer the recovery time will be. This is because the refrigerant molecules inside the system are moving slower, so it takes more time to move them out of the system. The second main factor affecting recovery duration is the length of the hose. The longer the hose, the longer the time it will take to recover the refrigerant. This is because the refrigerant has to travel through the entire length of the hose to reach the recovery device. Ideally, the hose length should be kept as short as is practical to minimize recovery time. Long hoses may cause excessive pressure drops between the system and recovery device. Earlier, we learned that recovery depends on pressure difference, so an excessive pressure drop may interfere with the recovery process.
John is trying to recover a refrigerant from a system, but it is too long. Which of the following elements of this recovery process should he address to improve the recovery time? Select the size of recovery cylinder. No. Ambient temperature of the system. Yeah. Type of vacuum pipe he's using. And the length of the recovery hose and the ambient
In this
temperature.
module, we define recovery
Yeah,
time
correct.
and discuss the various factors that affect the time it takes to recover refrigerant from a system.
Okay, the next one is dehydration.
In this module, we will take a look at the term dehydration and its effects on HVAC systems.
In our module on refrigerant oils, we learned that oils can chemically react with water to create toxic and corrosive acids. These substances can cause major system failures. For this reason, we do not want water or water vapor in the system. Dehydration is the process of extracting water and water vapor from the system. We dehydrate the system by evacuating it. The recommended method to dehydrate a system is to evacuate it. Evacuation is the process through which we remove all water vapor and air from a refrigerant system. A system is considered dehydrated when it attains and holds a vacuum of 500 microns or less. If the system contains a hermetic compressor, you need to make sure it is inoperative before you begin to create a dehydration vacuum. If the hermetic compressor is operating, it will prevent you from pulling a deep vacuum. In addition to removing all the water vapor from a system, evacuation removes all the air from the system as well. It is currently the most effective method for dehydrating a system. We may need to evacuate a system before any major system repairs. All the air and water vapor in the system is evacuated using a vacuum pump, which creates a vacuum inside the system. First, we need to make sure that the vacuum pump is capable of pulling a deep vacuum. We achieve a deep vacuum by pulling to at least 500 microns. In order to make sure that our readings for the vacuum are correct, we need to connect the system vacuum gauge as far from the vacuum pump as possible. This is because the gauge is sensitive and the movement of the pump can affect your gauge readings. Vacuum lines or hoses need to be equal to or larger than the pump intake connection. If the mouth of the hose is smaller, you would not be able to pull a vacuum. The piping connection to the vacuum pump should be as short in length as possible and as large in diameter as possible. To measure the final system vacuum, isolate the system, turn off the vacuum pump, then measure the final system vacuum. To measure correctly, we need to attach the vacuum gauge to the high side and vacuum pump to the low side. It is not possible to over-evacuate a system. The purpose of evacuation is to remove all the air and water from the system. You cannot remove too much air and water from the system because you want all of it gone. If you evacuate past the point that is necessary, it will not damage the refrigeration line sets because they are made of copper, aluminum, or steel. You will know that you have reached maximum dehydration levels when the vacuum indicator reaches and holds a vacuum reading of 500 microns or less.
Which of the following statement is false? It is not possible to over-evacuate a system. No, it's possible. A vacuum gauge is attached to the high level. Okay. Yeah. Vacuum line is needed to be small in diameter as possible. No. Completely dehydrated system hold a vacuum reader. Well, I think this is correct. Vacuum lines need to be short in
The
length but
dehydration time is
large
the
in
time it takes to
diameter
remove all
as
the
possible.
water and water vapor from a system. Dehydrating a system involves evacuating it by removing all the air and water within it. We generally want to minimize the amount of time spent dehydrating a system. The longer we spend dehydrating, the larger the risk of a component failing in the system. Your time as a technician is also valuable. That being said, we need to make sure we are taking safe measures to decrease our dehydration time. Safety is always number one. The following factors contribute to a system's dehydration time: equipment size, ambient temperature, amount of moisture, vacuum capacity, and suction line size. The larger the equipment, the longer it will take to dehydrate it. This is simply because there is more work to do. It's like mowing a lawn. The bigger the lawn, the more time it takes to get the job done. The ambient temperature is the temperature of the system. The colder it is or the lower the ambient temperature, the more time it's going to take to dehydrate a system. Heating up the system reduces the dehydration time. The higher the temperature, the less time the system takes to dehydrate. We can use a heat blanket to heat up the system safely. We never use a flame to heat up the system. Remember, these systems operate on possibly flammable materials under extremely high pressure. Using an open flame can lead to explosions. The more moisture there is in a system, the longer it will take to dehydrate it. Going back to the lawn mowing analogy, the amount of moisture in the system can be compared to the size of the overgrown grass on your lawn. The more grass you have to cut, the longer it will take to mow. Last but not least, the vacuum capacity is the rate at which your vacuum can pull out moisture and air. The smaller your vacuum capacity, the longer it will take to dehydrate the system. In other words, the smaller your lawn mower is, the longer it takes to mow the lawn. The longer the suction line, the longer it will take to dehydrate a system. That's why we want to keep the suction line as short as possible.
Which of the following factors doesn't contribute to a system high dehydration time? Appliance model, yeah. Equipment size, yeah. Its effect, vacuum capacity effect, ambient pressure effect. So the model is, yeah. The model appliance
In this
doesn't
module, we
directly
define the term
contribute to a
dehydration and
system
discuss the
dehydration time.
factors affecting the dehydration time of refrigerant systems.
Okay, let's go to the next step, this recharging the system.
In
It's
this
important
module, we will
part.
go over the details of the process of recharging refrigerant and discuss the precautions to take while servicing the equipment.
When working with flammable refrigerants, we need to take a few additional precautions before recharging the system. This is because flammable refrigerants can cause explosions and injuries if not handled properly. In previous modules, we learned that flammable refrigerants include hydrocarbons and HFOs. Hydrocarbons are generally highly flammable, or Class 3 according to ASHRAE classification. HFO 1234YF is mildly flammable, at Class 2L. For all hydrocarbons, we need to complete the following before recharging: electrically ground the system, install a fresh filter dryer, complete a standing pressure leak check at the maximum system pressure, and evacuate to 500 microns or lower. We need to ground the system before recharging flammable refrigerants. This is to reduce the risk of electrical fires when working with flammable refrigerants. We have to install a fresh filter dryer when recharging flammable refrigerants. Filter dryers absorb contaminants, so installing a fresh one reduces the chances of flammable refrigerants reacting with contaminants. We also need to perform a standing pressure leak check at the maximum system pressure. Leaking flammable refrigerants can cause fires or explosions. A pressure leak check ensures the system is not prone to leaking, even at its highest pressure. Lastly, before recharging with flammable refrigerants, we need to evacuate to 500 microns or less. This ensures that there are no contaminants in the system that the flammable refrigerant can react with. All of these steps need to be taken in order to make sure the flammable refrigerant does not cause an explosion.
Why do we need to electrically ground system before recharging it with hydrocarbon refrigerant? To avoid leaks, to avoid explosions, to avoid suffocation, all of our above. Okay, it's to avoid explosions.
During servicing, liquid
Yeah.
refrigerant can get trapped in the service hose between closed service valves. This happens when you transfer refrigerant between the system and a recovery unit. It's like using a straw. Imagine sipping soda through a straw. Even when you stop sipping, there is still soda in the straw. What happens to the soda in the straw when you let go of the straw? It falls back into the can. This is backwash. The same thing happens with refrigerant. You can think of the service hose as a straw. We want to make sure we don't trap any liquid refrigerant in the service hose. Any refrigerant trapped in the service hose will be vented when you disconnect it, which is illegal under Section 608.
Any refrigerant trapped in the hose after recovery is safe to vent? No.
In this module, we discuss recharging techniques and the procedures used during the servicing of equipment.
Okay, so now we finished the core of servicing. Okay, you know all this we are studying the general. After this we will study type 1 and 2 and 3 one by one. We finish servicing. Okay, we will go to the next one is leaks, and the last one is safety. So we will take this in this video. We'll take leaks, and the next video will take the last one, just safety. Let's take the leak. Okay. Okay, we will start with causes of leak.
In this
This is
module,
very
we will
important
discuss the
part
various
also.
causes of leaks and their effects on the HVAC system.
A refrigerant charge refers to how much refrigerant is contained in the system. For example, think of how many ounces of water are in a glass. The amount is typically given in units of pounds. lb. HVAC equipment needs to be charged with refrigerant in order to operate properly. If a piece of HVAC equipment does not have enough refrigerant, it cannot work properly. Typically, insufficient refrigerant causes reduced cooling capabilities. For example, if an air mattress has a small leak or hole, it will start to leak out air. It will no longer serve the purpose it's built for because eventually, all the air will escape. When refrigerant leaks, it means a harmful substance is being released into the atmosphere. This is especially true if we are dealing with CFC or HCFC refrigerants, which deplete the ozone layer. Refrigerants can also be harmful to humans if toxic and leaked indoors.
Which of the following is not a reason why refrigerant leak are concerned? They can easily be fixed by all homeowners. HVAC equipment won't work properly if there is leak. They can be costly to find and fix. Refrigerant can be harmful. Yeah, this is the most of our concern. Oh, it's not reason. Sorry. The net reason. Uh, the not reason. This can be easily fixed. The equipment won't. Yeah.
It's recommended to check
Yeah.
for leaks frequently because leaks are easier to repair when they are still small. Large leaks are harder to repair and can cause safety hazards. Both the repair of a leak and the replacement of lost refrigerant will cost money. The cost of both only goes up as the size of the leak increases. We need to check for leaks before charging a system. Charging a system means to replenish it with refrigerant. We find that leaks commonly occur at the following locations in the system: piping connections, equipment coils, valves, and where refrigerant piping enters or leaves a building. Leaks can occur for various reasons including the following: wear and tear, poor initial installation, and other construction. All equipment, HVAC or not, goes through normal wear and tear. As equipment ages, the possibility of a leak developing increases. This is just like us humans. As we get older, we go through wear and tear and find that our bodies get sick or injured more easily. If the equipment is not installed properly, it may lead to leaks developing, which might end up being costly to deal with later on. This is why only licensed HVAC technicians should work on these complex systems. Finally, leaks can occur because of other non-HVAC construction around the system. For example, a nail could be driven into a refrigerant pipe that is located outside the HVAC equipment. This could damage perforate the pipe and cause a leak to develop. If we find a leak in the system, we need to repair it immediately. Finding and repairing the leak, first of all, helps conserve the refrigerant left in the system. Imagine knocking over a full carton of milk. The sooner you stand the carton back upright, the more milk there is left in the container. This is how technicians approach a system leak. Finding and repairing leaks quickly helps save the refrigerant left in the system. There can be many ways to fix a leak depending on where the leak is and how big the leak is. One option is to solder or braze the leak on copper piping. If the leak is small and contained enough, you can use this method. A second option is to replace the component that has the leak, such as a faulty coil. If the leak cannot be fixed, the entire piece of HVAC equipment may need to be replaced. After a leak is repaired, the system should be checked to make sure it is working normally again. To check the fix, you need to evacuate refrigerant piping and pressurize with nitrogen. Gauges will show if the pressure is holding and if the leak was fixed. If the pressure matches the operating pressure of the system can be refilled with refrigerant.
If a leak is small enough, it's okay to solder or braze it shut. So I think it's true.
In this module,
Yeah,
we discuss the causes of leaks and learn how to fix them.
Okay, now we will go to the next one, is leak detection method, how we detect the leakage.
This module walks through the various leak detection methods used in the HVAC industry.
The first sign of a leak is typically a reduced cooling capacity of the HVAC equipment. This can be noticed when rooms are not sufficiently cooled, especially if it used to feel cooler at same temperature. The room may also feel a bit warmer than usual even when the system's cooling function is on. If all HVAC equipment components are working properly, the issue is most likely a leak. If you find that the system does not hold a vacuum after you evacuate it, this may also be a sign of a leak. A system that is leak-free should have no problem holding a vacuum. The first steps to finding a leak are the following options: no equipment required, visual inspection, and audible sound. The first step is a visual inspection. When looking over the components of the system, we want to pay attention to any traces of oil on the fittings. The presence of oil residue indicates a leak. Sometimes, a leak can be detected without using any additional equipment. You can listen for a hissing sound, which usually indicates a potential leak.
So right now we're looking at the indoor evaporator coil, and we're going to go ahead and open up the cover. We're going to use the back rack Informant 2 leak detector, and we're also going to use a bubble leak detector as well. We've had our back rack Informant 2 powered up for at least 30 seconds, so we're going to go ahead and sniff around. You want to move that probe real slow. Alright, so the tool just went off here. So it's going off anytime we get down low. So let me bring you in for a closer shot of that. So it looks like we have a leak up front. So right here is an up-close image with the bubble leak detector. I actually have a couple leaks on this right here on this system where the distributor tubes attach into the evaporator coil at. And you can see that the bubble action right there, it's making tiny little bubbles and it's kind of foaming. So that's what you're looking for, and that'll pinpoint your leak. So now we're backed up and you can see where the refrigerant leak is on the distributor tube on the evaporator coil. So that's one of them. There's another one towards the back. So that's how you find these leaks. You use the electronic leak detector and then you follow that up with the bubble leak detector too.
Which of the following are not common leak location? Piping connection, HVAC fan, coils, valve connection, HVAC fan. What are some of the common reasons why leak occur? Wear and tear on old equipment, poor insulation, holes or crack. Okay. Cracked accidentally during construction. All of the above.
Additional methods for detecting leaks are halide torch, ultrasonic leak detector, electronic leak detector, soap bubble test, and standing pressure test. A halide torch consists of a flame that changes color when there is a leak. Halide torches can only be used with certain refrigerants, such as R12 and R22. Halide torches cannot be used with hydrocarbons because hydrocarbons are highly flammable. An ultrasonic leak detector works by amplifying the sound of the gas escaping a system. This helps identify the area of leakage. An electronic leak detector senses the presence of halide gases such as chlorine and fluorine. Both ultrasonic and electronic leak detectors point to the general area of small leaks. After knowing the general area of the leak, we need to find the exact location of the leak. We can use the soap bubble test to pinpoint the leaks to start on making repairs. And lastly, we can test for leaks by doing the standing pressure test. For this test, first evacuate the system. Then we will pressurize the system and use an electronic leak detector to see if there are any leaks. We will discuss this test in detail in the next section. To summarize, there are many ways of detecting leaks. Generally, we want to start with a visual inspection. The most effective methods for locating the general area of a small leak are ultrasonic leak detectors and electronic leak detectors. In this module, we discuss reasons why it is necessary to perform leak tests frequently. We also went over different leak detection methods and when they should be used.
Standing pressure test. This is the next and last part of leak test. Of leaking. standing
In
pressure
this
test.
module, we will discuss various procedures and techniques that need to be followed while performing the standing pressure test.
As we
Let's
mentioned,
start.
the standing pressure test is when we pressurize the system and then use an electronic leak detection to identify the leak. When pressurizing equipment, we want to make sure that we don't exceed the low side test pressure for the equipment. The test pressure for equipment can be found on the equipment's nameplate. Make sure you do not exceed the low side test pressure as is indicated on the nameplate. We pressurize the system by adding a pressurized gas. Our options are dry nitrogen and a mixture of dry nitrogen and a refrigerant gas, for example, dry nitrogen with R22 refrigerant. When we mix R22 with nitrogen to do leak testing, this is called a trace gas. Trace gases are not considered refrigerants under EPA refrigerant management guidelines. Note that only specific refrigerants can be used for this method. For example, R22 can be mixed with dry nitrogen to leak check a system, but R12 cannot be mixed with dry nitrogen for this method. Before pressurizing the system, we need to start by evacuating it. Ideally, we should first recover the system to 15 pounds per square inch gauge. Technicians cannot add nitrogen to a fully charged system as it would contaminate the refrigerant in the system. Combining two refrigerant substances is not recommended. The resulting mix cannot be separated. Imagine adding orange juice to milk. You cannot separate the two liquids after mixing. This is why you cannot add nitrogen to a fully charged system. Recovering the system to 15 psig leaves some refrigerant in the system. Earlier, we learned that electronic leak detectors detect leaks by sensing refrigerant in the general area. There has to be enough refrigerant leaking to locate where the leak is. After pressurizing the system, we locate the leak with the electronic leak detector. Then, we have to recover the nitrogen and refrigerant mixture in a separate tank. If we use the same tank to contain both nitrogen and the refrigerant, it will cross-contaminate the tanks by leaving residue. If it were to be used to store nitrogen, the nitrogen would be contaminated by refrigerant residue. So we need to recover refrigerant in a separate tank. The EPA allows technicians to mix R22 and dry nitrogen to detect leaks. But as we said, once you have created that mixture, you cannot use it anywhere else. You also have to recover the mixture in a separate recovery cylinder. The method that would best serve the environment would be to pressurize the system with dry nitrogen. This is because nitrogen is a natural refrigerant that does not deplete the ozone layer. Dry nitrogen is typically the preferred gas for pressurizing refrigerant systems. Oxygen and compressed air should not be used. They can explode when mixed with compressor oil or flammable refrigerants. There are several safety concerns we need to be aware of when working with pressurized nitrogen. First, it is a pressurized gas, so it has the potential to explode and cause a lot of damage. Whenever we use dry nitrogen from a portable cylinder, we need to make sure that a relief valve is present. The purpose of the relief valve is to regulate the pressure of the cylinder. If the pressure is too high, the valve will release some of the pressure. The relief valve needs to be installed downstream of the pressure regulator. This ensures that it does its job of letting out pressure from the system when it builds up. When leak testing a system containing flammable refrigerants such as hydrocarbons, propane, isobutane, or HFOs, we must always install a filter dryer. A filter dryer removes the moisture and contaminants from the refrigerant. We must also perform a standing pressure test for systems with flammable refrigerants. For a system containing 50 pounds or more of a refrigerant, and with triggered leak rates, 2 verification tests should be performed. One is done before charging the system and the other after the system is working normally. We will look into the details of the acceptable leak rates for different systems in the courses for types 1, 2, and 3. In this module, we discuss what procedures to follow while performing the standing pressure test.
Okay, so in this video we finish the core of servicing, and now we will finish the leak. We have only the leak quiz. Okay, let's finish it, and after this revise the contents, and we finish this video. Let's go to leak quiz. Oh, we have 3 questions. Which of the following is common way that leak can occur? Wear and tear on the old equipment, poor initial construction, holes or cracks created accidentally during the construction, all of above. Which of the following is least likely to be common leak location in HVAC? Piping connection, HVAC fan, coil, valve connection, HVAC fans. Which of the following is not reason why refrigerant leaks are concerned? They can easily be fixed by all homework. Yeah, because this one, HVAC equipment won't work properly if there is leak. We must take care of this. They can be costly to find and fix. Yeah, refrigerants can be harmful to the environment. We will take care of this. Okay, let's finish and submit. Okay, now we have 10 of 10, so we answered all correctly. Okay, let's finish this review. So in this video we finished servicing, okay, the 3 R's and recovery equipment, and factor affecting recovery, and dehydration and recharging. After this we finish core leaks, causes of leaks and leak detection methods, and standing pressure test, and we finish with the quiz.
Experience more ways to play and sync your